Thank you all for coming, and thank you for voting for the talk. I'm rather pleasantly surprised. I hope you're all having a good day and a good time at DroidCon, and I'll be speaking about gesture animation today. A little bit about me. I am Kinnera. You'll find me in Frankfurt. I'm currently an Android developer at EOKI. Also, if there's some desert, you can find me there. Next, so just a little preview of what we're going to be doing today. There is this absolutely addictive animation that you can see on screen. You pull up, and then it either sticks to the top or the bottom, and then it's very stretchy, very sticky, super addicting. I had so much fun implementing this on the Android view system, and then I re-implemented it in Jetpack Compose. So I really want to share how these two things are very different, but also quite similar. So these are the things that we'll be discussing today, no particular order. The first thing is a stretchable square. We'll be basing our gesture animation on this square. Number two, we're going to be talking about ViewDragHelper, and also in discussing why not the Android drag-drop framework. Number three, just dynamic animation. Do we really need this when we're already using drag? We'll find out. Number four, we'll be implementing 1, 2, and 3 in Jetpack Compose, and we'll see how this is considerably concise. Not necessarily simpler, but definitely concise. I like both of the implementation. Jetpack Compose tends to abstract a lot of the code that I, for one, have started to get used to. So I'll let you decide which one you like best. So you know gestures, you know animation, you know all of the drag and drop, you know the spring animation. But how do they go together? We're going to find out today. For the sake of brevity, I will be omitting some of the code, so please check the source code later for a more workable implementation. All right, let's get started. First, we have a stretchable square. Let's define the square first. We need bounds, so we'll start with 4 points, start positions on the x and y, and let's go ahead and define this data class. Next, we're going to draw a path starting from the start position on the left and going back in the clockwise direction. Great. Now we have the square. It's an arbitrary square, but we have our square. So let's go ahead and draw it. In the view system, we would extend a view and then override on draw to draw this. In Jetpack Compose, we have the canvas layout component, and then we'll just draw the path inside of this canvas. Pretty similar so far. We're not really abstracting any of the code here. Next, are we done with the stretchable square? Not yet, but for now, we're good. Let's go ahead and look at the Android drag and drop framework. So, quick question. Does the Android drag drop framework actually drag the object? Can we have a show of hands for yes? Now for no. And a lot of maybes, I take it. All right. So if anyone knows, why not? Since no one raised their hands for yes, I'll go with no. Anybody know why? Oh, I have a duck to give away, so. All right, let me go ahead and tell you. With the Android drag and drop framework, we can move data with the graphical drag and drop gesture, right? We can move from one view to another. This includes a drag event class, drag listeners, we have helper methods and classes, but does it actually drag the square? We're not actually dragging the object in this case. What happens is the system responds by calling back to your application and then getting a drag shadow, which is what we're going to be defining here. We're using a shadow builder to define the shadow that will actually be dragged when you drag an object. The object itself disappears before the shadow is shown. All right, so we're overriding on-touch event here, and then when you actually click on an object, we're going to start dragging it with the shadow builder. All right, next, what we're going to do is we want the square to actually go back to the top or the bottom. We want it to reset when you stop dragging it. So let's go ahead and reset the y coordinate to 0. Now, this is what it looks like. We're dragging it, and then there's a split second of disappearance before it resets to its original position. So let's see what the problems are with this. Number one, it doesn't allow direction constraints. So we can drag it all across the screen. Number two, not exactly the smoothest. If we used drag stopped, for example, instead of drag ended, we probably would have a slightly less split second of time where it disappears. But we do want that direction constraint. So let's go ahead and see how ViewDragHelper can help with this. So first, we're going to create a ViewDragHelper, add a parent layout with this ViewDragHelper, and we're going to extend the callback for the ViewDragHelper. Now, this has a lot of functions that are really useful. What we're going to start with is try capture view. We don't want to use the drag gesture when the touch is outside the square. So we're going to override this method to capture the view when the pointer ID is within the given square. What happens when we're already clicking on the view? It doesn't actually access try capture view anymore. It automatically results in true without consulting the callback. And we're going to use this incredibly useful function called clamp view position vertical. I'm doing nothing else but telling Android what kind of range I want the square to be moving in. So this is working. There's no square yet, though. We have the ViewDragHelper, but we haven't actually drawn the square. So let's go ahead and define the stretchable square that we defined before. We're going to use onLayout to make sure the layout knows where to draw the square. And then we'll add onMeasure. Because something I've noticed is that the width of the square after a drag is it kind of resets in a worst-case scenario to an edge that we don't expect. So we want to make sure that doesn't happen. OK, still no square. It's not moving. We have the ViewDragHelper. We've drawn the square, but it's not draggable yet. A little frustrating. So no throwing anything at MacBooks. They're kind of expensive, unless your company is paying for it. Then it's OK. OK, so what we need to do is we have to allow the ViewDragHelper to process the touch events that is being received from the square. So let's go ahead and do that. So now, it works somewhat, but the square goes up and beyond the app bar sometimes. There it goes. So what we're going to do now, earlier we just went ahead and did the bottom half of the screen. So here we're going to make sure it doesn't go beyond the top or the bottom. So we have it very well in range. We're there. We're dragging it across the screen. Not really smooth at the bottom, if you notice. There we go. There's a little laggy animation there. So let's see how we can fix that. With Compose, though, before we go there, can anybody guess how many lines it'll take? All of this ViewDragHelper stuff. Anybody? 3? Anyone else? 5? All right. Anybody? 1? Oh, OK. All right, let's see. It is 5, which is you, almost. If you count the brackets, yeah. Pretty cool, right? All we need to do is have a box with constraints, have a modifier object with these modifier class functions. We have something very useful called draggable here. Just set the orientation to vertical, and we're all done. Really cool. I love it. OK, so now we're going to go ahead and do something else. What we're going to do is check whether the square is in the top half or the bottom half. And then we want it to go back to the top or the bottom. So we're going to just check if it's less than or more than the half the height of the screen. OK, so to settle that little tiny lag at the bottom, we're going to use something called settle capture viewEd. What this does is that it handles a smoother animation down to the final position that you expect. So here the final position is if it's at the top, it's 0. Otherwise, we're going to go down to the bottom. So if you can see, when it comes down to the bottom, there's a rather smooth settling happening. It's rather subtle, but it does make a difference, which is important with gesture animation, right? We are always implementing drag-drop animations, and we're making sure that this is a part of the user experience. But when you're doing something that everybody else is doing, you want to make sure there's a little oomph added to your drag gestures. It makes a big difference to users, even if it's not completely noticeable. OK, so now we're going to go back to the square. We just drew the square before, so we have to make it stretchable. What do we need to make it stretchable? We need 2 things. We need the scale for translation, and we need the stretch factor. So let's start with the stretch factor. We're just going to define a float in the same way that we defined all of the bounds before. And we need it to go as close to the center as possible. But we don't want this really awkward triangle happening. So we're going to go ahead and divide it into 10 parts, and then go with 4 and 6 so that we don't have that tiny edge at the end. OK, so we're also going to define something called control point. When we draw quad curves, we do need that control point to be able to do it. But we'll be doing the same way as the bottom trailing point. So let's go. So earlier, we drew the line from the top to the bottom. Instead of that, we're going to go ahead and do quads now. This makes sure that it's changing along with the drag gesture. All right, so just to recap, with 0, it's going to be a square. And with 1, we have the not awkward triangle. All right. So now that we have our stretch factor, we're going to define the scale for translation, which is directly related to how far it is from the top or the bottom. All right. Now, this is really interesting. We need something called stuck and unstuck here. Stuck means that we want it to be stuck to the top or the bottom until a certain threshold, which we will define here. And we need something called just unstuck, which is that little moment in time where it's reached the threshold value. Why do we need this? We'll find out in just a little bit. All right, so now that we have our scale for translation and the stretch factor as a direct dependence on the translation, we're going to go ahead and implement this. So we will override the on measure that we did earlier, but in this case, we're going to go ahead and add our scale for translation. So we're here right now. Before the scale and stretch happened, we had just the square going up and down. We can drag it, it stays to the top or sticks to the bottom. We're going to add our stretchable now. So what we're going to do now is override the same extend the same callback that we used try capture, view, and the clamping before. And we're going to override on view position changed and on view released. In this case, what it does is on view position change is called every single time. There is a lot of times that it's called during the drag process, and it will update the stretch factor and the scale as we go along. And when it's released, we want it to go back to its original square size. All right, so Jetpack Compose. We just have it on one screen. All we need is a remember draggable state to configure the stretch dragging for this UI element. And it also does the single orientation. Now, so the drag distance is reported back to this remember draggable state, and then we use this delta to allow users to react and update their state as we go along. What we have here that is similar to on-view position changed and on-view released is the callbacks for on-drag started and on-drag stopped. So this is a part of the remember draggable state, and just as simple. More concise, but really the same. We're defining the absolute translation, we're defining the stretch factor, and we're updating the square just the same. All right, so now this is what we have. It's scaling, it's stretching. We have a couple of issues. So anyone tell me what the issues are? There are two of them. One, I think, is pretty obvious. It doesn't flip at the bottom. Number two, anybody? Sorry? That is a good one, but no, I don't think we're fixing it in this one. Sorry? It is, we want it to be vertical, which is what we tried to do, right? We clamped it vertically, and we made sure that it remained in the same vertical. Yes? Yes, exactly. So what's happening is that, sorry. All right, so it flings back from the bottom to the top when it comes down, if you notice. It doesn't go back from the top to the bottom. When we're stretching something, we want the top to come and meet the bottom. We don't want the bottom to come and meet the top. So that's something that we need to fix. How do we fix it during drag? Not really. So let's go ahead and see how we can do this during dynamic animation. First, let's fix the flip at the bottom. This is easy enough to fix. If it's not at the top, we can just scale it, and it goes opposite. Remember draggable state in Jetpack Compose is actually very easy because they have a reverse argument. You just set it to true. All right, so now that we hear a dynamic animation, we're going to make sure that it flinks back from the top to the bottom instead of bottom to top. So let's see how that goes. So what is dynamic animation? The property animation system allows you to animate anything. We can define an animation to change over time. So to animate something, what do we need? We need 4 basic things. We need an object property that we want to animate. We need an object's position on the screen. We want to know how long the animation is going to run. And we want to know what values we animate between, right? To know more about dynamic animations, check out Nicole's talk yesterday on composable sheep. That was really good. OK, so now let's add a little bounce. See that one? It's so cute. It made so much of a difference to how the draggable animation did earlier. It was smooth before, but now you can really see it come back. It's not super obvious, but it comes back. How do we do this? We use spring animation. We define y as what we're going to be animating. We're going to set a velocity. We're going to tell it how long it's going to animate. And we're going to tell it a damping ratio so that we have that little spring and bounce when it comes back. All right, so we have a little bounce. Now, what do we want to do about the fling from the top down instead of the bottom up? This is where just unstuck comes into play. And it's really interesting. So when it's just unstuck, we want it to spring back from the top to the bottom before it can do the other way around. So what do we do here? We are going to use an animator set. There are two pieces to animating properties like this. We first calculate the animated values and then set those values on the object and property that is being animated. So object animator here is a subclass of a value animator, which is the more generic form of it. It does not carry out the actual setting of values. So we're going to listen to updates and then set them ourselves. This animator set sort of groups animations to go together. Here, we are going to animate 3 things back. One, we're going to have the Y to be back to that position. We want the scale to go back to the initial square position. And we want the stretch factor to be back to 1, right? We don't want any of those. We want all of those things to go back to the original position. So let's go ahead and see how that works. There. So pretty. I love it. OK, so how do we do this in Jetpack Compose? They have a lot of options. There's an insane amount of options. This flowchart is up on the developer or Android page, so you can take a look. In our case, we want a state-based composition. We want to update multiple values at the same time. So we're going to go ahead and use update transition that's right in the middle. All right, so in animation for Jetpack Compose, there's something really interesting. We can define an enum class, in this case box state, but I'm using the same things that I did in view state and going ahead with normal, stuck, and just unstuck. So here, update transition that we use here in the composable sets up a transition and then updates the target with the target state, right? So when the target state changes, the transition will run all of the child animations together, all of the values that we mentioned in this state, and then go towards that target's values reached by the new target state. So we don't actually have to mention each of them separately. Now let's see how this can be done. In this case, let me give an example of stretch factor. So in this case, we have to define the state first. So we're going to define stuck the same way that we did earlier. And then in both the just unstuck and the normal state, we want it to be in its original position. So we have a transition spec where we're going to say that when the box is going from stuck and to just unstuck, we want it to spring. So if you notice now, there's a little spring even when it's getting unstuck. It's not obvious, but it does improve the quality of the animation. The drag itself feels more intuitive. You can really feel that thing going together. Now, just to go back and compare what we did in view system. We did the spring animation the same way, much simpler in Jetpack Compose. We're also going to explain how this is happening in Y offset. So the same thing that we're doing for the stretch factor, we're going to be doing for Y offset and scale for translation. With the transition spec, we don't have to define everything together. We only have to define the transitions that we really need. In this case, we're going to spring between just unstuck to normal. So if you can see now, when it goes from just unstuck to normal, you can see that little spring in its step. It improves the quality, like I said before. OK, so just to compare again, this is what we did with the view system. We did an animator set with a bunch of object animators for all 3 of those things. And this went into a particular function. But in Jetpack Compose, you can obviously do that better. So in Jetpack Compose, what I did notice is that you need an exact modifier chaining, which is always a little challenging to find, because there's a lot of documentation for it. You know there are a lot of things that exist, but what do they really do together, right? I'm sure you notice this with padding, where you do it just before another and just another after, and then you can see a difference in the way the padding changes in Compose. So I think it's really interesting to be able to see what we can do just with chaining and moving around things in the modifier object. So this is what we have with Jetpack Compose. I know it looks the same, but it feels much better. All right, so just as a summary of what we've done today, first, stretchable square. We defined stretch factor, scale for translation. We drew the square, and we defined it. Next, we talked about ViewDragHelper. I know it was a big implementation, but it worked. We also know why not the Android drag and drop framework. It is a wonderful framework to use for very specific use cases, but it's also really helpful to be able to override ViewDragHelper and create a more customizable option. Next, we talked about dynamic animation. Spring, spring, spring. I'm sure I said cute a lot of times today in this presentation, but it is cute. So please go check it out. And also Jetpack Compose. I loved working with Jetpack Compose. I think it improved the quality of the code itself to be able to make sure, go back, and not feel like I've entered a different world. Because that usually happens with a lot of things that we do with XML. Go clicking through things that we did 2 years ago and then not know what we were doing before. So I think that part got a little better. Thank you so much. I'm Kinnera Priya on all social media platforms, so you can talk to me any one of them. I would love to hear suggestions, critique, improvements, anything that you think we can do with animations. This is something that I'm very passionate about. I'm also happy to answer any questions. I might not have all the answers yet, but we can always look for them together. Yeah, I had a lot of fun speaking here today. Thank you for having me. I hope you did too, and I look forward to speaking with you later.